Welcome everyone to this River Publishers book discussion. I'm Philippa Jeffries and I have with me Vladimir Kopta to talk about his forthcoming book, Integrated Power Management, A Quick Start Guide. Vladimir, thank you so much for joining me today.
Thank you. Nice to be here with you.
Could you start by introducing yourself a little bit and the book?
Okay, yes. So I'll start basically with my education first. So I did a bachelor at the University of Belgrade in electrical engineering, and then followed with a master's at EPFL in Lausanne, Switzerland. So translated to English, this is a Swiss Federal Institute of Technology in Lausanne. And then finally a PhD, which was a kind of collaboration between EPFL and CSCM. Which is the institute where I work now. So CSCM is, and I would like to maybe just briefly mention this to give some background, is a Swiss Center for Electronics and Microtechnology. And basically, there are a lot of people working on many different topics there. One of them is electronics, and more precisely, low power electronics, which has somehow historically developed due to the watchmaking industry that is in the Neuchâtel, and the surrounding region. And the low power comes from basically electronics that was initially developed for wristwatches. And as people, at least at that time, wanted to have something that would, using a small battery, last for a couple of years, low power was basically the emphasis of the design. And that has actually stayed the case until today. But we have a broader spectrum of things that we're designing right now. So it's not just low power watches, it's wireless communications, CPUs, AI accelerators, image sensors, and so on. So my PhD was in wireless communications. And then after that, I basically switched gears a little bit and I started working quite a bit in the power management domain. So basically, the circuits that supply power to all these low power devices that we were working on. So that's somehow how I got into it. And as I got into it, initially I had some background. I had some courses in grad school. I knew about power electronics and power management, but this was somehow the first practical experience I've had. And the idea for the book basically came as a kind of my way of explaining to someone else what I would have liked to read at the time when I was starting. So hence the quick start guide. So that was the initial purpose of the book.
Okay.
Yeah. Yes.
Well, great. Thank you. And you kind of mentioned it a little bit by talking about the importance of low power. But my next question is, what is the importance nowadays of power management in chips? Like, why is this so vital?
So just to continue with this whole low power aspect, you have a lot of battery power devices nowadays, starting with laptops, smartphones, tablets, smartwatches, and a lot of other devices that are actually maybe you don't pay attention to, like temperature sensors or whatever it is. And all of these battery power devices need to somehow be supplied. Now, power management is the part of the circuit that actually provides the supply to the device itself. So it takes the battery voltage, converts it into whatever the voltage you need, and needs to do this in a very efficient way, because a low power circuit itself is not very useful unless you have an efficient way to perform this power conversion. And this is basically what the book is about. Now, this is also the importance of power management. So somehow it's never quite in the spotlight. So the power management itself is somehow a side thing, but it's just as important if you want to have an efficient device and a device with long autonomy and so on. Now, power management itself is a very broad topic, and actually the book is mostly about low power systems, as I said, because of my background. And we're talking here about Internet of Things type of devices, so sensor nodes, microcontrollers, things like this that have a lot of different integrated functions, and a power management that is basically integrated on the same chip together with the rest of the system. So as opposed to maybe power electronics in general, where engineers would usually talk about amperes of power consumption and very high powers that can be quite dangerous. Here we're talking about a few milliamps or hundreds of milliamps or something in that order of magnitude. as opposed to this kind of field where you have high power electronics here, our goal is basically to maximize efficiency, simply to increase battery life. And these chips, so it's a little bit, the whole game is a little bit different. So we don't care about power dissipation and a lot of other things, but we have these sensor nodes, let's say, that are sometimes off, sometimes on, sometimes consume a few milliamps, sometimes a few microamps and even nanoamps. And in all of these different regimes, you need to make sure that the power management itself is very efficient and doesn't burden the battery itself. I don't know if I'm getting a bit too technical here.
Yeah, no, it's all very interesting, and you kind of touched on it just there. But yeah, I was wondering what some of the challenges are when designing integrated power management systems.
Yeah, exactly. I basically already got into efficiency, and it's essentially so. If you ask me about challenges, it's somehow make it small and make it efficient. But this is basically something you could say for literally any integrated circuit out there. And as you probably know, the semiconductor industry has developed immensely over the past 50, 60 years or so. So we managed to fit quite large devices into something that is maybe a small square of 2 by 2 millimeters. So this integration, this whole process of miniaturization, that's something that's generally applicable. And also in the power management, maybe maybe 20, 30 years ago, or even a bit less, power management was a separate thing. So you would buy a chip or several chips that would perform this role. Now it naturally somehow went on to become part of the same system on chip and to essentially coexist with all the other circuits and all the other functions on the same silicon die. And again, the importance, why we're even talking about this, is that there is a gap in the voltage that is required by silicon and the voltage provided by the batteries. Now, today you have different batteries with different characteristics, but typically lithium batteries would provide around 3 volts. And now you have more advanced technological nodes that usually require sub 1 volt supply. So it seems small, but actually this difference is quite significant if you're trying to power a device for a few years, or if you're really caring about power efficiency. And this is where this power management comes into play. So again, all about efficient power conversion. And then, also I forgot to mention, so yes, indeed the newer technology nodes can use power supply as low as maybe, let's say, 0.7 volts, but then different parts of the chip may still require higher voltages, or maybe even higher than battery voltage, or maybe some specific applications. So all of this falls under this power management role to supply whatever is needed, and again, to do it efficiently.
Okay, and the way you approach power management within a chip, is that very specific to individual devices? Or can it kind of be more generalized?
It's very difficult. Well, there's no one magical solution that will fit all applications. So, and this is why, and you won't find it in the book. But rather, what I wanted to achieve was somehow to translate my thought process in this book. So the way I approach design, and for me, this was my goal with the book, to somehow give my experience to someone else, to somehow allow younger or less experienced engineers, or those that have not worked on integrated power management for low power systems, to somehow kickstart their design, and to know where to look, what is important, and then essentially to gain some intuition when it comes to this topic. So some things can be generalized, but a lot of things are application dependent, and again, my goal was to show in the book how to approach these different problems that are commonly found. Now, it's difficult to cover all of them, especially since this is a River Rapids series, so we are limited in space. But I wanted to cover this one topic and somehow to explain in a slightly more general way how to approach this design issue. And what the challenges are, because like I said, you have a lot of literature on the power management and power electronics topics already, but this is a specific problem with its own set of challenges that I try to address here.
Okay. And the book gives someone some place to start, right, when considering this problem.
Yeah, exactly. So again, even even for this, let's say, relatively focused topic, it is difficult to cover everything. So I
Hmm.
tried to be as general as I could, to provide also some of the basic theoretical foundations. But here I'm also assuming that whoever is reading the book already has some
Hmm.
background in electronics, in IC design.
Hmm.
And then finally, to provide some guidelines and some more advanced techniques, and then push the reader to read a bit more on the topic because it's difficult to cover all of it.
Yeah,
So,
but it gives a good foundation and some
yeah,
practical advice.
exactly. So, like I said, that's somehow why I called it the quick start guide. So, this is
Hmm.
somehow get up to speed, get the basic design techniques, the way of thinking, and then you can continue with further reading and then research on your own.
Hmm. Great. Well, thank you so much, Vladimir. We've kind of come to the end of our time, but
Okay.
yeah, thank you so much for joining me, and yeah, congratulations on finishing your book.
Okay, thanks. Yeah, it was nice to talk to you today. I'm actually glad I got the opportunity to write this book. It was a bit more challenging in the end than I hoped, but
Hmm.
I hope it will be useful for other engineers out there.
Hmm. Great. Thank you.